we'll look at some of the homework problems in section 9.1. And in 9.1, we were talking about how probabilities are determined. And these are problems that are related to that. In this first problem, the spinner shown on the right is spun. Assume that the size of each sector is the same. Here you want to find each probability. In part A, you want to find the probability that you're going to spin to get a factor of 10. Well, spin a number that is a factor of 10. Okay, now to figure this out, factors of 10 is this. You want two numbers that will give you a product of 10. One of them will be 1 and 10. So here a pair of numbers, 1 and 10, because 1 times 10 will give you 10. Also, 2 and 5 is another pair of factors that will give you 10. Okay, now in this case here, the wheel is from 1 to 8. Well, we do have a 1, we do have a 2, and a 5. There are three numbers that are factors of 10. So the probability of spinning a number that is a factor of 10 will be 3 over 8, because there are 8 numbers on this wheel. Part B, the probability of spinning a number that is a multiple of 7. And in this case here, there's only one number that is a multiple of 7, and that's of course 7, because 7 is a multiple of itself. So the probability of spinning a number that is a multiple of 7 will be 1/8. Okay. All right, problem number 2. A marble is selected at random from a jar containing 6 red marbles, 4 yellow marbles, and 5 green marbles. What is the probability that A, the marble is red, B, the marble is not yellow, C, the marble is either red or green, and D, the marble is neither red nor green? Okay, so let's answer the question of what is the probability that the marble is red. Okay, let's add up how many marbles we have altogether. There's 6 plus 4 plus 5, which will give you 15. So here you just add in those those three numbers together, the 6, the 4, and the 5. So there are 15 marbles altogether. Now we want the probability that the marble is red. Well, there are 6 red marbles out of a total of 15. So the probability of getting a red marble out of the jar will be 6 over 15. Now they want us to simplify the answer, so we have to reduce 6 over 15 by dividing the numerator and the denominator by 3, which will give us 2/5. So the probability of that the marble is red will be 2/5. Part B, what is the probability that the marble is not yellow? Probability that the marble is not yellow. Well, let's look at the probability of selecting a yellow marble, by the way. In this case, there are 4 yellow marbles out of 15. So the probability of selecting a yellow marble will be 4/15. Now we want the probability that it's not yellow. This right here is the complement of yellow, of a probability of getting a yellow marble. So we'll do 1 minus the probability of getting a yellow marble, which is 4/15. So if there are 15 in the bag, that means the rest has to be 11 out of 15. Or you can think of one whole as 15 over 15. But in this case here, or you can think of this. There are 4 yellow marbles, so that means if we can't select a yellow marble, then it has to be either red or green. So it'll be 6 plus 5, which will give you the 11 over 15. So in this case here, the probability that the marble is not yellow will be 11/15. And it's already in simplest form. Okay, part C. What's the probability that the marble is red or green? Okay, so we're looking at a red or green marble. Well, in this case, we need to find the probability that it's a red marble, which is, of course, 6 over 15, plus the probability of getting a green marble. There are 5 green marbles out of 15, so that'll be 5 15ths. Okay, and I'll leave 5 15ths as is because I want to keep the denominators the same so I can add the numerators easily. So 6 plus 5 will be 11 over 15, which is the same as the probability that the marble is not yellow. So in this case here, part C, well, the probability that the marble is red or green is also 11 15ths. And then next was the probability that the marble is neither red nor green. Well, the probability of getting a red or a green marble is 11 15ths. That probability would have to be this, 1 minus 11 15ths, which is, of course, 4 15ths. Okay, if it's neither red nor green, then that means that the marble has to be, of course, yellow. And there are 4 yellow marbles there, so it'll be 4 over 15, or the probability that the marble is neither red nor green. Okay. All right, the next problem. Anne has 9 unmarked computer disks in a box, where each is dedicated to exactly one of English, Spanish, French, mathematics, computer science, biology, SAT preparation, college applications, and American history. If she chooses a computer disk at random, what is the probability that she chooses the mathematics disk? And what is the probability that she chooses a disk that is neither mathematics nor SAT preparation? Okay. Now, in this case, there are only 9 computer disks, and one of them is mathematics. So the probability of selecting a disk or computer disk that is mathematics will be 1/9. So it'll simply be 1 over 9. And then what's the probability that she chooses a disk that is neither mathematics nor SAT preparation? Okay, well, mathematics is 1/9. And for the SAT preparation, it's also 1/9. That'll give you 2/9. But you want neither mathematics nor SAT preparation, so you want the remaining 7. Or you can think of this as 1 minus 2/9, which is 7/9. So the probability that she chooses a disk that is neither mathematics nor SAT preparation would be 7/9. Okay? You can think of this intuitively as this. If we don't want mathematics or the SAT preparation, then that means we want the remaining 7. So it'll be 7/9 as your final answer. Okay, next problem. According to the weather report, there is a 57% chance it will rain tomorrow. What is the probability that it will not rain tomorrow? Okay, this is where we can use the complement here. Now, 57% as a decimal is going to be 0.57. If you recall, you always drop your percent sign, move the decimal point 2 places to the left, or you can drop the percent sign, divide by 100 because percent means per 100. So 57% would be 0.57. And then, of course, the complement of that would be 1 minus 0.57, which will end up being 0.43. So the probability that it will not rain tomorrow will be 0.43. Okay. All right, the next problem is this. Sentinel High School was found to have the number of students listed below. There are 479 freshmen, 503 sophomores, 536 juniors, and 482 seniors. If one student was chosen from the school, what is the probability that the chosen student is a sophomore? Okay, now we need to take the sum of all of the students in that particular high school. So if you add 479 students to 503 students to 536 students and 482 students, you're going to get 2,000. So there's a total of 2,000 students in that particular high school. Now, in this case here, we want the probability that the chosen individual is a sophomore. And from that table, there are 503 sophomores out of 2,000. So it'll be 503 over 2,000. And 503 over 2,000 is in simplest form. So in this case, the probability of selecting a student that is a sophomore would be 503 over 2,000. Okay, next problem. If A and B are mutually exclusive, and the probability of event A is 0.5 and the probability of event B is 0.1, what is the probability of the union of A and B? Okay, if you recall what mutually exclusive is, it means that events A and event B have nothing in common. And there is a way that we can find the probability of the union of A and B, which is the same as saying the probability of A or B, which is simply the sum of the probability of event A and the probability of event B. So the probability of event A was 0.5. The probability of event B was 0.1. So if you add 0.5 to 0.1, you're going to get 0.6. So 0.6 will represent the probability of event A or event B. Okay, next problem. "55 men and 65 women are enrolled in calculus. There are 20 business majors, 40 biology majors, 50 computer science majors, and 10 mathematics majors. No person has a double major. If a single calculus student is chosen, find the following probabilities." And in this case here, we want to find the probability that the student is a female. Okay, we got 55 men and 65 women. So if you add 55 and 60 together, you're going to get, 65, I'm sorry. 55 and 65, that would give you 120. So there's 120 men and women. And we want the probability that the student is a female. Well, there's 65 women or 65 female out of 120. So that probability there will be 65 over 120. Okay, the next problem is find the probability that the student is a computer science major. All right, in this case here, there are 50 computer science majors in this particular situation. And this is out of 20 plus 40, that's 60, plus 50, which is 110, plus 10 is 120. Okay, so in this case here, the probability of selecting a computer science major would be 50 out of 120. Because of the factor of 50 computer science majors out of a total of 120. Okay, next is find the probability that the student is not a biology major. Okay, now if we want to exclude the biology majors, which means that there are 40 biology majors, if we want to exclude that, we want to add just the business majors, the computer science majors, and the mathematics majors. So if you add 20, 50, and 10, you're going to get 80. And that's 80 out of 120. So the probability that the student is not a biology major would be 80 out of 120. And may I please go back to these other problems because they want us to simplify your answer here. So let's see, if we divide by 5 here for 65 over 120, this will be 13 over 24. Because I'm dividing the numerator and the denominator by 5. For this one, the second problem here, for the probability of a computer science major, it will be 50 over 120. But if you reduce that, it's 5/12. And now for this one, 80 over 120, that's going to be divided by 40. That's going to give you 2/3. Okay. So do pay close attention to those directions where they ask you to simplify your answer. Okay. And then the last one was find the probability that the student is a computer science major or a biology major. So in this case here, we want a computer science major or a biology major. Well, for a computer science major, there are 50 out of 120. So in this case, this will be 50 over 120 plus the number of biology majors. There are 40 biology majors out of 120. So it'll be 40 over 120. Now, if we add 50 and 40 together, you're going to get 90. So it'll be 90 over 120. And 90 over 120, when you reduce that, would be 3/4. Okay? So make sure that you simplify your answers in simplest form and type them in the form of a fraction. And finally, the last problem here. In a refrigerator, there are 12 bottles of diet soda, 6 bottles of regular soda, and 3 bottles of water. Find the probability for the events consisting of the outcomes listed below. In part A, they want the probability of choosing a bottle of diet soda when the bottle is chosen at random. Okay, we got 12 diet soda bottles. And then we need to add how many total bottles that we have in the refrigerator. So it's 12 plus 6 plus 3. This will give you 21. Okay, so there are 21 bottles in the refrigerator. And in this case here, there are 12 bottles out of 21. 12 diet soda bottles out of 21. So the probability of selecting a bottle of diet soda at random would be 12 over 21. And 12 over 21 can be reduced by dividing the numerator and the denominator by 3, which will give you 4/7. In part B, find the probability of choosing a bottle of regular soda at random. Regular soda. The 6 regular sodas out of 21, so it'll be 6 over 21, which will be reduced if you divide the numerator and the denominator by 3, 2/7. And then part C, the probability of choosing a bottle of water at random. There are 3 bottled waters out of 21 total bottles in the refrigerator, so it'll be 3 over 21. And 3 over 21, if you divide the numerator and the denominator by 3, 1/7. Okay, so that's how we find probabilities here. Okay, and that should be enough to assist you with some of the homework in section 9.1.